Most modern encryption uses two prime numbers to create a private key. It's easy to create this number, yet difficult to reverse. How do we find these numbers? With a quantum computer. Firstly, we only need numbers that share factors with n. Then we'll use the GCF to find the factors themselves. So we'll start with a random guess g, say 7. This number shares no factors with n. However, here's a useful discovery. For any two numbers a and b which do not share a factor, there exists a number p where a to the power of p is a multiple of b plus 1. We can modify this formula, and boom, now we have factors. Now our theorem also has a subtle implication that will benefit us greatly later on. A to the power of any random number will be a multiple of b plus a remainder, and a to the power of any random number plus p is actually a multiple of b plus that same remainder. Now first thing we'll do is we'll create a superposition of all numbers from 1 to n. And then we'll simultaneously for all superpositions, we'll calculate g to the power of the superposition. Now we'll find the modulus between this power and n. Now we'll read in random difference, say 4. Think of quantum superpositions as a spinner. Now you can have all the values of the spinner as you like, but when it's time to read those values, you simply spin the spinner, and whatever you get is what you read. It doesn't matter what we get, because when we read this random difference 4, it collapses all superpositions, and so now what's left is all the superpositions with the remainder 4. Now we can't read the superposition directly, however we know all our values are p apart, thus we'll use a quantum Fourier transform. When we supply this Fourier transform with a specific frequency, it will output superpositions with multiples of that frequency. For our case, we'd get these values. We can simply pick a few of these states at random and quickly find the common factor p using the GCF. Given that p is even and isn't a multiple of n, we've got our factors. And so that's how you can break world-class encryption with nothing but a quantum computer.